Have you ever wondered what solar panels on rooftops do, how they work, the way the shimmering glass produces electricity out of almost pure nothingness except sunlight? Well, here we will take a look at the components that play a vital role in harnessing the sun's energy to deliver electricity to homes and businesses all around the world. And if you haven't already, hit the like button below. So, what is solar energy? Solar energy is the sun's radiant light that is harnessed through different types of ever-progressing technologies. This is a huge opportunity in the next couple generations to reduce things such as climate change or just better technology. This includes solar heating, solar thermal energy, solar architecture, photovoltaic, molten salt power plants, and artificial photosynthesis. To put it in layman's terms, solar energy is the conversion of the sun's heat into electricity. Solar energy has been used for thousands of years all over the world, and it is one of the oldest methods of heating, cooking, and drying. In modern days, it is used to make electricity where there are no power or electric supplies, like faraway continents where people live, or outer space. These days, it is becoming cheaper to make electricity from the sun's heat because it is always giving heat and light. Solar energy is the cleanest and most bountiful renewable source of energy available, and the United States has some of the biggest solar resources in the world. Solar technologies harness the sun's energy for different uses, including providing light for the environment, heating water, or for generating electricity, or to be stored in batteries or thermal storage. Photovoltaic, solar heating and cooling, and constrained solar power are three main ways to harness solar energy. Photovoltaic produces energy directly from the sunlight via an electronic procedure and can be used to power anything from road signs, calculators, lights up to homes and businesses. Constrained solar power and solar heating and cooling both collect energy from the sun, and they use this heat to provide hot water, pool heating, and cooling for residential, commercial, and industrial practices. Solar energy is very adjustable. It can be built at a central station or a utility-scale power plant. Both of these methods store the power and energy they possess for dispensing after the sun sets, using revolutionary solar and storage technologies. Solar exists within a complicated and joined electrical system in the United States, working together with other technologies like wind to transform the United States to a clean energy financial state. The way solar power is produced is by photovoltaic cells that convert sunlight to electricity in the form of direct current that is passed through an inverted power supply that transforms the direct current electricity into alternating current electricity. The alternating current electricity is then used to power on lights and other appliances. Well, how do the panels work? How does it produce the energy that gives light to your house? Well, the sun acts as a nuclear reactor plant, and while a chain reaction takes place inside the sun, energy is released. That energy becomes photons, which travel through space in all directions, and some of them end up on Earth. That photon reaches the Earth in just about 8 minutes. The photons are absorbed by the solar panels that are made from silicon, which is a semiconductor. The solar panels has two parts. One side is made out of the silicon that is mixed with metals to make it negative, and the other side is metals to make it positive. When the cells of the panel get stuck to the protons, they spark off the electrons, which separate them from the molecules they were attracted to. An electrical current is then produced by the electrons that float to the other side of the cell through connectors that join the positive and negative sides. When multiple panels are connected together, they can produce a large amount of electricity. You will find it typical at homes that would have a set of solar panels set together. Photovoltaic panels, on the other hand, produce direct current electricity because electrons move from one direction through a circuit, from the negative through a light bulb, and then through the positive side. Electrons move in both directions with alternating currents. It is much easier to send alternating electricity over long distances, which means it makes it full use of the energy from the solar panel it needs to transform. And if you haven't already, please give a like. This took a lot of research, and I would appreciate it. Now, back to it. Solar inverters are responsible for important functions like providing ground fault protection and offering statistics on the amount of power developed. Ground fault protection is just another way of saying the supply is grounded, so any electricity leaks run off safely instead of potentially electrocuting someone. During the earlier days, central inverters were used, but recently microinverters came into the picture. They boost the supply of energy in each solar panel, rather than distributing the entire system at once. This is a key feature because it empowers every panel to achieve its highest potential. To know how much power a panel can make depends on where your current location is, how much sun your panels are exposed to, and if your panels are getting any shade. So, if your house is situated in the middle of skyscrapers, like in the movie Up, then even on the sunniest days, you won't be getting a huge amount of power. If you live in the countryside and your roof is getting enough sun, you will be getting loads of power. The advantage comes in that you can use power to fund your own electricity needs, unless you are at work or school when your panels are at their highest. Then you can still gain from a grid-linked system. During daylight, the grid-linked system will produce energy and feed it back to the grid for other individuals to use. You will receive credit for it, which will be removed from your electricity bill. This is only a small amount of what you could get from the government. The government has several incentives for you to get solar panels. In the near future, solar panels will pay for themselves, where all of us will save money. Let us take a look now at the two types of solar energy technology: the solar thermal and solar photovoltaic technology. Both technologies collect the sun's power and convert them into energy. They each just do it differently. Photovoltaic energy refers to the photovoltaic effect, where a photon affects a panel composed of semiconductors, where silicon is the main element. During the time when the photon crashes into the semiconductor, it releases electrons. That reaction produces electricity through exposure to light. Semiconductors are the core element of solar cells and are shaped into thin layers that generate an electric current. These semiconductors trap the moving charge, then converts it into electricity for houses and businesses. With solar thermal technology, the thermal utilizes on the basis that water moves around in tubes in the solar panel, while the sun rays heat it. Tubes hold the fluid and rotate it through the heating system with the use of pumps. Water then circulates using a method of submissive heat exchange. It is a natural method based on diffusion. As the fluid boils, it will push the cooler water. Residential solar thermal heating is normally fused with backup boilers to supply year-round heat and hot water. Solar thermal energy is used to heat walls, water, and is used for home heating, ceiling, and roof piping in. Solar photovoltaic cells generate electricity while solar thermal systems generate heat. While both of these operations are energy efficient, solar photovoltaic only works during the day when there is sunlight. It can work on cloudy days, but the energy generated capacity will lower by 20 to 40%. Most solar thermal systems have hot water tanks that are used to store heated water until it is needed, because battery power has not progressed enough yet. Solar energy is steadily growing worldwide, with more and more individuals realizing the immense benefits of solar panels. In the United States, solar panel installation has grown from 0.35 gigawatts in 2008 to 97 right now. And if you haven't already, please drop a like in this video. Videos like this take a lot of effort and time and hours to make, and I would greatly appreciate it, and it would help the channel.